Good morning to all. Myself Professor Archana from IIT ISM Dhanbad. We are in course of Introduction to Python and Petroleum Data Analytics. In the last class, I have started data wrangling and pre-processing. Under this topic, we have started with the feature scaling, where the two things absolute maximum scaling and min max scaling we have covered. In the today's discussion, I am going to focus on the normalization. Under this, again we will be discussing min max normalization, max apps normalization, mean normalization, standardization or Z-score normalization. Then we will go ahead with robust scaling, log scaling and category scaling. So what is this normalization? So normalization is the process that transform your data features to a standard scale, typically between 0 to 1. So talking about this 0 to 1 and transforming data or your data feature to a standard scale, we have done this mean max scaling in the last class. Okay, so what we do achieve? This is achieved by adjusting each feature value based on its maximum and minimum values. So the goal is to ensure that no single feature dominates the other due to its magnitude. That means no feature should give the preference based on the numerical value. To why to normalize? It improved model convergence, then fairness across the feature, and then it enhances the interpreting the result. So comparing and interpreting feature importance is easier when they are on the same scale. So these are the different reasons. That's why we do go ahead with the normalizing the features. So first under this one, types of normalization techniques, we have the mean max normalization. So we can call that mean max scaling as well, which we have started in the last class, and it is known as the rescaling as well. It is a popular normalization technique that rescale the data to a common range, usually between 0 and 1. So this is how we are going to achieve that. X normal will be X is the each feature value and xi minus x mean by x max minus x mean. So this is the way we do calculate the x normal. So just understanding this one, if we do have a data set of age ranging from 18 to 80, to normalize this feature using mean max scaling, what we are going to do, 18 is the minimum value and 62 and your 80 is the maximum value. So the range would be 62. Range of the data is the 62, and what we will be doing, each feature we are going to subtract by the minimum value, that is your 80. So this way we will be proceeding. So taking that one, that's the first one. Okay, now when we move to the second one, that is a max apps normalization. So what is this? Scale each feature by its maximum absolute value. So how it would be? X normal will be calculated by xi by x max. Okay, so to do this one, I have taken the example here where I am calling from scikit-learn pre-processing, importing the max app scalar and importing the numpy, and this particular max apps normalization I am doing on the data that is a array. Okay, and we will be doing the normalization on that, and this is the array. After normalization, what we are getting, we are getting the range, all the feature will be scaled to 0 to 1. So this way what we say, it is a normalized. Okay, so to proceed this one, we will go to the code window and do the operation with the. Okay, to start with that, I move to the repeated notebook. Okay, and I will show the operation how does it work. Okay, so you can see this window. Okay. Now proceeding with this one, first we require to call this from scikit-learn dot preprocessing import your max apps scalar. So from scikit-learn preprocessing import max apps scalar. Okay, then we are working with the num array, so import numpy as np, then create one array. So take a data equal to np, okay, dot array, then create a data by putting the value 10, like -5, 20, okay, and then take one more, that is a 30, 15, -10, then go to the third one, -20, comma 0, comma 5. Okay. So this is the way we have to do, create that one. Okay. Now data has been created. So print data. Okay. What you see here. Okay. So this is the data I'm going to work. I'm going to normalize this one. Okay. After that, next create comment, create a max apps scalar. Okay. The next we are going to create that object max apps scalar. Okay. So start with the comment, create a max apps scalar. Now next what we are going to do that? To create that we require to write a scalar equal to max apps scalar. Okay, so this way we initialize it, we have created. Now scale data, create one variable scale underscore data I have taken here and equal to scalar dot fit. Okay, scalar dot fit transform, and I am passing the above data. It passed here. Okay, now I want to scale. So this the I want to print the scale data. Print scale underscore data. That's the one we wanted to print. Now just check this. Okay, put one white space here, line space. Okay, so for that we know what is the syntax, \n and close it. Okay, so this is the data. Okay, what you can see it here, this is the array which I have taken. On this particular array we want to apply the max apps normalization. Okay, to do this, okay, what we have to do, we require to create a max apps scalar object given the name scalar I have given. Then I am initialize this one max apps scalar. Okay, next what we have to do, we require to scale the data. So one more variable is created, that is scale underscore data equal to scalar dot fit transform data. Okay, so this the my array, this is the array which is initially. What it does, as per the formula, x and the maximum value it will be divided to, and that way what will happen, it will give you the max apps scalar. Okay, so in this it will have the column wise operation. So we do have the 10, 30, 20, it is in the first column. So what is happening, maximum value is 30. So what will happen, 10 by 30, so 0.033, 30 by 31, then 20 by 30, 0.67, like that it will work. When we will go to the second column, maximum value we do have a 15, so minus 5 by 15, it will be 0.33, then 15 by 50, 0 by 50. So how it is working, it is taking the maximum value from each column and it is dividing, and this way it is rendering column by column. Okay, and it is doing the operation, and then we are getting the scale data, this is the one. Okay, so this is about the max apps scaler. Okay, so this the one thing. Okay, now this one I have not discussed because last class I have taken the example and we did this activity. So just I skipped it. Okay, but this is also as part of a normalization technique. We are taking mean max normalization. Okay, now this we have done max apps normalization. Now moving to the next one, that is a mean normalization. So the mean normalization is a way to implement feature scaling. Mean normalization calculates and subtract the mean for every feature. Okay, what does it mean? First, you require to calculate the mean. Feature means what? We are talking about the column. So this is my table. So this is the feature we are talking, each column. So this is the column 1, column 2. So these are the feature or attribute. So if we are working on this particular, so you require to calculate the mean of this feature. So in the data corresponding to each column, what will be first the calculation, mean calculation will take place. So in the mean normalization, calculate and subtract the mean for each feature or every feature. A common practice is also to divide the value by the range or the standard deviation. So when we do talk about the range, how does it work? It will range means if we are talking about the particular feature, so what is the maximum value for that and what is the minimum value for that. Okay, so this is the way to calculate the mean normalization. So x dash x minus mu is the mean. Okay, and x is the point for that I am doing this normalization or data point. So x minus mu by max of x minus mean of x. So this is the way. So it centers the data around the mean and scale its range to -1 1. Okay, so for that also there is a one example taken of the data frame. Okay, and the data frame is created using the dictionary key value pair, and then the normalization is being done using the mean normalization on the feature 1. So feature 1 is the one and on that normalization is done. So we can also proceed this one. Okay, so how to proceed it? Okay, so we will take one example. We will go to the code window. Here I was. Okay, now next example we are taking for this one. We are taking one again data equal to, we will create a dictionary. Okay, so dictionary creation, just take a feature 1. Okay, feature 1. Okay, and then take the value as this. So I take 10, 20, 30, 40 and 50. Okay, and then again comma feature 2, put inside the quote, this is my string. Okay, colon, and then I do have the another value, that is a 100, 150, 200, 250, 300. Okay, like that I take. Then create that to the data frame. So df equal to pd dot, okay, I have not imported the pandas. So first import pandas as pd. Okay, now go here pd dot data frame. Okay, and then pass the data to that. Okay, and print your df. Okay, what you see here, you see the data frame which is having the column feature 1 and feature 2. I want to just to do the normalization on the feature 1 only. So how we will be proceeding? Create one variable mean underscore feature 1, and then we are doing df of feature 1. Okay, feature 1 then call the mean. Okay. So that's the one. Then we want the max mean also as per the formula. So max of feature 1, this is another we are calling variable. We are assigning the variable and df of feature 1 I want feature 1. Okay, close it and then calculate max. Similarly, max of feature, that is a mean. Okay, max we have calculated, so correct it to mean and then df of feature 1. Okay, and then that is the mean value. So that's the one thing. Okay, now after doing what we have to do, we require to put df of one column I wanted to create, that is a feature 1 underscore normalize. That value I wanted to get it included here equal to this value I am putting to feature 1. Okay, and then okay minus, then we require that mean feature. Okay, and divided by max feature minus mean feature. That's the thing. Okay, now you print that df. Okay, that's the way here. Okay, what I would be doing along with that, I am interested in seeing the result for all this value what it has calculated. So just print that along with this. So that's the one. Then we wanted to see all this. What is the max mean? So just take this one. Max. Then we have taken mean as well. Okay. This is the all we wanted to print. Okay, just print this one. Okay. Somewhere there is a mistake. Let me find it out. Where it is. Okay, it is here. Then start here and then here it would be closing. Okay, run this one. Okay, so this is the one. Okay, so this is the mean feature. Okay, so if I want this to be get printed, okay, then colon and comma. Then this way it will be more clear what is the mean max value. So do this one like that. Okay, and similarly for this one. So there is some more we wanted to check out with this. Okay, so this is my data. Okay, 10, 20, 30, 40, 50. So this data on this particular, this is the piece of the code which is written for the mean normalization. So we have created one data frame and it is having the two column, feature 1, feature 2. Feature on feature 1, what we wanted to do, we wanted to apply the mean normalization. For that, what we require to do, I am creating one variable, okay, and putting the feature 1 mean on that one. Similarly, checking what is the maximum value. So my maximum value is 50 here as per this data, you can see it here. And the minimum value I do have here as per this record 10. Okay, so it is printed it here and it has calculated the mean for that column feature 1 and the value is 30 Now what we did, we wanted to apply the normalization, so we required to put the formula. So x feature minus mean, so and by max and mean. So that we have calculated. So this way we are able to do the mean normalization here. Okay. So this done. Now we will go to the code window. Now we will go to our presentation mode. Okay. So this the mean normalization we do talk about. Okay. Now the next we do have the standardization or Z-score normalization. So this we call the Z-score normalization, or we may call the standardization as well. So it transforms data into a standard normal distribution with a mean of 0 and a standard deviation of 1. Okay, that's the thing here. So here previously that was not the case, but when we do talk about the standardization or Z-score normalization, in this case, this is the with mean 0 and standard deviation of 1. So this technique is useful when the data follows a normal distribution. Okay, so just we if we do have a data set and with a feature height and with a mean of 175 centimeter and a standard deviation of 10 centimeter, if this is the case, to normalize this feature using Z-score normalization, we would subtract the mean from each height and then divide by the standard deviation. Okay, so this is the formula. What is after scaling x scaled is xi minus x mean by standard deviation. Okay, so when we do this one, this would result in a normalized feature with a mean of 0 and a standard deviation of 1. So this method of scaling is basically based on the central tendency and variance of the data. Okay. So central tendency is here mean and variance is your standard deviation. Okay. So I have taken the data which is a sample data. Okay. If you see this one, starting with import pandas as a PD, then we have put it one data frame that is df1, that we are putting this data, that is pd.read underscore csv we are using, then reading this csv file here, and once you wanted to see the here top 20 record, so df1.head20, that is the print. So what the record it is shown, it is these many record is shown. Now we are applying the standard scalar on this data. So this the code we do have, scalar is equal to standard scalar, then scale data scalar dot fit dot underscore transform, and then finally we are getting the scale data and the record is being shown for the 20 record. Okay. So this I will explain. So first we will go to the code and see this one. Now we go here. Okay, and now we will start with first I wanted to fetch the record. Okay, so let's see how many record are there. So first import pandas as pt, that's the one thing. Then next what we have to do, we require to read that data. So df1, one variable I will assign pt dot read underscore csv. Then I want to read it, so let me check the path. So this is the data and this data I am using. So sample data, copy as a path, go to the code and this one. Okay. Now first I am interested to see the record. So how many record are there? 1460 rows and 2 columns. We do have the column lot area ms subclass. Okay. So this operation standard scale currently we are doing on the CSV file, and here we do have the two record, that is a column lot area and ms subclass. Okay, so put that into the print df1. Okay, so this one. Okay, now next I am interested in doing the standard scale or Z-score standardization. Okay, so we will start with from scikit-learn dot preprocessing. Okay, we require to import the standard scale underscore df equal to pd dot data frame. Okay, and then here I have the parameter scale data, and then we do have a columns equal to df dot columns. Okay, and then closing this, then I wanted to print scale df dot head 20 record I wanted to see. Okay, so this is the thing. Now there is some error. Okay, so this let's see the error. Where is it throwing the error? Line 4. Okay, we wanted to do that. df1 dot column here. So this is the mistake here. Okay, so I have put it by mistake df, so I have to put df1 because that's the name I have given for my data frame. So that's why the error was appearing here. Okay, it has taken some other data. Okay, frame that is name of df in the particular this code. Okay, so we will start with, this is the standard scalar we are working, or z-score standardization, or z-score normalization. Okay, so from scikit-learn dot preprocessing import standard scalar, then scalar equal to standard scalar scale data scalar dot fit transform df1. Okay, and scale data pd dot data frame scale data which just now we have transformed, and the column name which wanted to retain from the original one, and then print scaled underscore df, and then how many record we are interested to see here, 20 record. So this the information we are getting in the scaled form. Okay, or z-score normalization. Now one by one we will see this one, how it works. So first line of the code we do have the from scikit-learn preprocessing import standard scalar. Why we are giving the more preference here to this line of the code? Because moving on we are going next to the training and testing, where this all is going to be important. So we require to understand it properly. So the line from scikit-learn dot preprocessing import standard scalar is the first line here. Okay, is a Python import statement, and it is used to bring the standard scalar class into the current namespace or scope from the scikit-learn.preprocessing module. Okay, so what is the purpose here? Why we wanted to call this or import that standard scalar here? So this standard scalar class is a crucial component in data preprocessing for machine learning. Okay, and what it does? The primary function is to standardize feature. How we are doing? In our case currently we are doing removing the mean and scaling to unit variance. So how we are doing that? Subtracting the mean of each feature from its respective value. So what is the formula we do have? If we do have the scaled here, if we will write x minus mu by standard deviation. So what is the mu? It is nothing but the mean for each feature, and this is nothing but your standard deviation. Sigma is the standard deviation. Okay, so this is the one thing. Scaling to unit variance, so divide each feature by its standard deviation. This ensure that all the feature have a unit standard deviation or variance. We can call that standard variation or variance. So the second line of the first we are clear what it does. Second line of the code is scalar is equal to standard scalar. Okay, so it initializes an instance of a standard scalar class. So that is the one, scalar is equal to standard scalar. Okay, so the purpose of the standard scalar here, it is again we are using for feature scaling. Okay, it standardizes feature by removing the mean and scaling to unit variance, and this transformation is known as the z-score normalization. So how it works? For each feature or column in your data set, the standard scaler calculate mean of the feature and standard deviation of the feature, and scaling will be done this way. Okay. So after this transformation, feature will have the mean of 0 and a standard deviation of 1. Okay. So the second, moving on, then we reach to the third code, that is scale underscore data, that is equal to scalar dot fit transform df. Okay. So it's a common operation in machine learning pre-processing, particularly for feature scaling or normalization. So the breakdown here, one is the scalar, and then we do have the here fit underscore transform. So talking about the scalar first, so this refers to an instance of a scikit-learn pre-processing class. Okay, so in our case that is a standard scalar. Sometime it will be, when we work along with the min max scalar, it would be min max scalar, or when we do talk about the robot scalar, it would be robot scalar. So after that, coming on, we will be talking this robust scalar as well. So these scalar are designed to transform the feature of a data set to a more suitable scale for machine learning algorithm. Okay, so this is nothing but we are talking about the scalar. So df, okay, so df which is inside this one, so df represents the input data, typically a pandas data frame containing feature to be scaled. Okay, now the talking about this one, fit underscore transform. So this is the method provided by the scikit-learn scalar that combine two distinct steps. First one is the fit and the another one is the transform. So fit, so in this step the scalar learns the necessary parameter from the input data df. Okay, for example, if it's a standard scalar, okay, it calculates the mean and standard deviation for each feature in it. So this is the step. What it does, it calculates the mean and standard deviation for the particular feature. Okay, and if we are talking about the min max scalar, it determines the minimum and maximum value for each feature. So these learned parameter are then stored within the scalar object. So once it learned, where it is getting stored, it is getting stored in the scalar object. So talking about the transform, after the fit step, okay, the transform method applies the learn parameter to the input data df to perform the actual scaling. So this transformation will be done once it reads the value. Okay, once it gets the value, what it is doing, it is transforming from the learned parameter. So the original value in df are transformed based on the calculated mean, standard deviation or mean max value, resulting in a scale data. So that's the scale data. It will be result and put it here. Okay, so if we will take all this together, scaled underscore data equal to scalar dot fit transform df, what it means, the scalar object is first trained on the df to understand its statistical properties, that is a mean, standard deviation, mean and max. Then based on these learned properties, the df is transformed and the resulting scale data is stored in a scale underscore data variable. Okay, so this is the very important step here. So we are discussing in detail. Now after that, what we do have, scaled underscore df equal to pd dot data frame scale data comma column equal to df dot columns. Okay, so we are talking about this particular step. So it creates a new pandas data frame, and what its name, scaled underscore df, which I have given it here. So this operation is typically performed after a numerical data set has undergone a scaling or transformation process. In our case, currently what we are doing the standardization, okay, using the standard scalar from scikit-learn. Okay, so this is the breakdown here. We do have the scale data under that one parameter, and another one we do have the column. So scale data, this is an array like object, okay, containing the numerical data after it has been scaled. So this scale data has been passed here as a parameter inside this pd.data frame. frame. Okay, so the scaling process transform the original values to a new range or distribution which can be beneficial for the certain machine learning algorithm. Now the scale data is the one which is already has been transformed from the original data. Then the second parameter we do have column equal to df dot columns. Okay, so this argument, okay, assign the columns names from an existing data frame df to the newly created scaled underscore df data frame. So what it ensures? It ensures that the scaled data retains a meaningful label for each feature, making the scaled underscore df easier to interpret and work with, as the column correspond to the original feature before scaling. Okay, so this is the one. Lastly, we do have the pd dot data frame, and this each individual we do talk about. So what is this pd dot data frame? This is the pandas constructor used to create a data frame object from the provided scale data and specified column. And lastly, this line of the code, print scale df dot head 20, it gives you the 20 record after doing the scaling. Okay, so this is the another important thing which we do talk about, that is our z-score normalization. Now we have reached to the robust scaling. Okay, so in this particular method, this is another method for the scaling. So in this particular method, we use the two main statistical measure of the data. That first one is the median and another one is the interquartile range. So we are aware about what is median and interquartile range. So we will just recap. So median is the middle value in a set of number. Okay, when we arrange this number into ascending and descending order, if data set has an odd number, okay, so median will be the middle value, like 1 2 3 4 5. So this is the odd number. So this is already in ascending order we have arranged. Okay, so 3 would be the median, but if I have the 6, so total 6 record I do have, so median would be 3 plus 4 by 2. Okay, so this is the way we calculate the median. So robust scaling, we are focusing on the two data, that is the median and interquartile range. So after calculating these two values, we are supposed to subtract the median from each entry and then divide the result by the interquartile range. So this is the scaled data would look like that. So how the scaled data? We are going to scale the data. Xi, that is the data which I wanted to scale down. So Xi minus X median by IQR. So median we know, IQR also we know IQR is nothing but the interquartile range. So how to calculate that one? IQR we are calculating Q3 minus Q1. Okay, so what is this? Q1 is the first quartile and it represents the value below which 25% of the data points fall. When we do talk about the Q3, that is the third quartile, it represents the value below which 75% of the data fall, and Q2 is nothing but the second quartile and also known as the median. It represents the middle value of the data set. So just we to talk about. So this is about the robust scaling. So when we do talk about the coding point of view, so how to proceed this one? First we will be importing the data. So for that, import pandas as a PT. Then I wanted to read the data from this CSV file. So df1 is my object, data frame object, df1 equal to pd dot read underscore CSV. Then you require to pass the path. Then print df1 dot head 2020 record. It is displayed here. Now to do the scaling, robust scaling, what we are doing from scikit-learn dot preprocessing, import robot scaler. Okay, then scaler equal to robot scaler. We initialize this one. Then scale data we are doing scalar dot fit transform, and we are passing this tf1 which just now we have created it here. So this the previously I do talk about this standard scalar. Okay, so the same concept applies it here. First what it is doing, from scikit-learn pre-processing, it is importing the robot scalar which is required here, and then we initialize that robot scalar. So scalar equal to robot scalar. Then we scale the data. This line of the code, what it does, it takes the value what is required here. In this case, it required the median, and then the second parameter, it is required the IQR. So for each column, what it does, it calculates the median and IQR value. Okay, and then it does the calculate, and then the does the calculation on each data, and then the data would be put it back to the, it will read the data, okay, it will calculate it, then it transform it, and then it put into the variable scale underscore data. Okay, now we wanted to put that into data frame, so scale underscore df, so pd dot data frame, then we pass that data, which just now we have a scale underscore data, and then column name, same column name we wanted to retain. So once you do, then I wanted to check how many records are there. So we wanted to check first 20 records. So scale underscore df data frame, that is a new variable dot head 20. So this is the record we will be seeing. So this is the way we can use the robot scaler here. Another scaling we do have, that is a log scaling, is another method for normalization technique that is useful when the data has a skewed distribution. Okay, so these techniques involve taking the logarithmic of the data to reduce the effect of extreme values. Okay, previously we do talk about the outlier. Okay, and we do have the data like mean max scalar, and then we do talk about some other data. We do have a data like mean max scalar, so where we were talking, okay, it is a uh, if we do have the outlier present, it would be biased to that. Okay, so here when we do have a data and we want to reduce the extreme values, this is going to be helpful. Okay, so how to proceed that one, I have taken one example for data frame. Okay, so this import numpy as a np, then import pandas as a pd, then we have taken a sample data with a skewed distribution. So you can see this here, you do have data for 10, 50, 200, then the other record are even lakh, 5,000, 1,000. So what you can see, it is not normally distributed. It is the scenario of the skewed data distribution. So created one data frame, df is equal to pd dot data frame data. Then wanted to check the original data. So just print original data and then get the value. So this is the one we do have. Once it print the original value, this is the data frame it has created, and it's the value, column name is value. Okay, that's the one thing. Now going to the second one, apply log transformation natural logarithm. Okay, so here df, okay, and what we want, I wanted to create one new column, that is log scaled value. So df log scaled value equal to np dot log function we are calling, and which column I wanted to pass, that the value column value. Okay, now print the df. Okay, so now you can see this one. Okay, here the result, this is the result we do have. Okay, this is the result we do have. Log scaled value np dot log df value. So this is the result we do have. Okay, and what we want, we wanted to print this one. So this now df, once it will get printed, now it has the column added, that is a log scaled value. This is the one scenario. Another scenario is taken when the data is having the zero value. Now the data has the zero value. Okay, so in this case, if you just read this comment, apply log transformation natural logarithmic, add a small constant 1 if your data contains 0 or negative value. Okay, so what it does to avoid the issue with log 0 or log negative numbers. Okay, so to handle that one, here what we are doing, we are having the data which is having the 0 value. To how we are proceeding this one here. So data with 0, so the data is put it here. Now you wanted to check this one, so df underscore 0, so pd dot data frame data with 0. So this is the value we do have starting with the 0. So we do have the 5 record, okay, where the value, one value is 0. Now this is the record displayed it here. Now apply log 1p transformation for data that might include 0. Okay, so how to handle that, this scenario, df underscore 0 log 1p. So this is the very one column I have added. So log 1p underscore scaled value, np.log1p. Okay, so now what we are doing, you calling the log1p and then df0 value we are passing. So what it does, it handles the situation of the 0 when we call the log1p. Okay, when there is no 0 we will be calling that log function. Okay, so this is the way we will handle if you do have the 0 value present in the data. Okay, another normalization, we do have the decimal scaling normalization. So the objective of the decimal scaling normalization is to scale the feature values by a power of a 10. So ensuring that the largest absolute value in the each feature becomes less than 1. Okay. So when it is going to be useful? When the range of the values in the data set is known, but the range varies across feature. Okay. So the formula for the decimal scaling normalization, how we are proceeding? X decimal equal to x by 10 to the power d. So what is d? D is the smallest integer such that the largest absolute value in the feature becomes less than 1. Okay. So d value we require to keep anything. So whatever the largest value we do have in our feature, that would become less than 1. If I have, like, take this one, this is the example, it will make you more clear. Okay, if the largest absolute value in the feature is 3500, then d would be 3. Okay, so the feature would be scaled by 10 to the power 3. So if I have 3500, okay, and what I wanted, d value I want 10 to the power 3. When I will be doing this one, so this is the way my maximum value will become less than 1. Okay, so this decimal scaling normalization is advantageous when dealing with the data set where the absolute magnitude of the values matter more than the specific value. Okay, so currently we do not have any feature in scale and preprocessing, like we do have talked about the here robust scalar, then we do talk about standard scalar, but currently we do not have something for decimal normalization. So for that, what we require to create a function and then proceed with that. Okay, so this is about the decimal normalization. Now moving on to the last one, it is a categorical scaling. So categorical scaling involves transforming categorical data into a numerical data. So how it would be done? Techniques such as one hot coding and label encoding are the common use for the categorical scaling. Example, suppose we have a data set with a categorical feature like color that has a three category: red, green and blue. What we want, we would use one hot coding to transform this feature into the three numerical feature: red, green, blue, each with a value of 0 or 1. Okay, so this way what we do, we go ahead with the categorical scaling. When we do have the category, when we wanted to change into the scaling, what we will be giving, we will be giving some number. Okay, like if you have the female and male for gender in any column, gender is a column, and this the female and male is a category, so we can put it for female 0 and male 1. So whenever there is a female, I am replacing with the numerical value that is a 0, and for male I am changing with the numerical value 1. So this way, category with a one hot coding or labeling, we are able to do the categorical scaling. So in the today's class, I do talk about the normalization. So that's the mean max normalization, ABS normalization, mean normalization, then standardization and Z-score normalization. Then further we do talk about the robust scaling, then log scaling, and finally the categorical scaling. This is all for today. See you in the next class. Thank you.